let's talk about why we should use functions. So there is one saying, don't repeat yourself. So instead of writing the same code several times, instead we make it a function and we can call out this function several times. So it's you can say that, for example, if we have this block here which has some functionality, then we use the same functionality here. And for example, here in our code, there are some other lines also. Instead, we can say that, let's say that this is a function f, and now I can call this f in my code several times where I want to. Also, what is nice with your code is that now if I would like to add some functionality into every part of my code, I should do it several times. Now I instead write it inside this function f, and it applies to everywhere where I have the function call. So yeah, if you already see that in your code you have certain lines which are repeated, you should think about making it a function. Depending on your IDE, PyCharm, for example, shows you a warning if you have repeated code, and then you can see that you can maybe have a function for that. Even if there is some certain small difference, let's say there is a value 7 here and 11 here and 8 here, so you do something with the value, then you can have this as a parameter in your function. So here you can call f7, here you can call f11, and here you can call f8. Of course, f is not a good name for a function, but just to get the point through, the idea is that instead of repeating your code, you just write a function and call out this function with different parameters, so you can also kind of change the behavior of this part of the code, but the main part is the same, maybe only the value, I don't know how many times you repeat something or what you print out and so on. Yeah, so the repeated code should be put into a function. And now, if I want to change the functionality, add something here, I can do it just only in one place. So I change the function and it's changed for every place I use this function. Abstraction. So function user. So if I'm the user of the code, or I'm the another developer who takes your code and wants to add something to it, I don't have to understand actually how the function works. I only need to know that it does something. I want to know what it does. So for example, it calculates something, but I don't care about the contents or the body of the function. It can be, I don't know, let's say it's 100 lines long. So if I don't have the function, I only have this 100 lines of code. Of course, I can add a comment here, so I say that complex stuff. But instead, I can have a function. The function can have a meaningful name. For example, calculate salary based on your previous year. And now if I see that somewhere in the code there is this calculate function called, I understand that, yeah, okay, this function does that, and I don't actually care how it's done. Of course, if I want to modify it, then I have to know what's done here, but usually I just want to use this function to do something additional. So I just see that there is a function, I can call out this function, I can read out the function description or the docstring, and I don't actually want to go into details with this function. So I expect it to be working and so on. So I can basically say that for me, this is an abstraction of this functionality. I can use it, and I don't have to go into this into the details with this function implementation. And yeah, I can divide a complex or big program, or the big program into sub-programs or sub-problems. So instead of let's say you want to have a program which helps you to finish your studies. So instead of writing a program which kind of has thousands of lines of code, what you have to do to complete your studies, and instead of maybe having a function study, we instead would like to divide it into smaller tasks. So usually, let's say you study 3 years, you usually divide it by the years. So first year, second year, third year. Also 1 year is usually divided into semesters or something like that. So instead of that, you maybe also have the first semester, second, third, fourth, fifth, and sixth. And of course, the semester itself contains different subjects. So maybe you just want to have study math, study computer science, study history or something like that. So you divide your bigger problem, like studying in university, into smaller problems. And then it's easier to tackle those problems. And also it's easier from the maintaining the code part. So if I want to maintain the code, or my code goes to another developer, it's easier to understand and work with it if I have several small sub-tasks or functions instead of one really big. So this 100 is actually not a good example. So instead you should probably divide it into smaller functions still. Also, testing your code is easier if you have smaller tasks. So if I have a one program study and I want to test whether this function works, whether this function does what it should do, then what I can do, I can call out this study function and see whether the result was correct. If it's correct, then it's maybe okay, but if it's not correct, if the result or the output or whatever, the end result is wrong, then it's very hard for me to actually understand why this is wrong. But if I have smaller problems here or smaller functions, then I maybe see that this one, let's say those first two are okay, third one is not okay, the fourth one is also okay, and let's say those fail. And now I can go into those functions and see what is the problem with my function, what happened here, what was the expected value, what was the actual value, and then maybe tackle the problem there. So it's easier to maintain and test your code if you have smaller functions. Then you can get a better overview of testing. For example, instead of having just a report which says that the study fails, which it does, but it's very hard to understand why it fails. But if I have a function called study maths and it fails, then I already know maybe not so precisely, but it's still better. Of course, it would be even more sensible to kind of divide also the studying process into smaller parts. For example, maybe taking one course contains of different sub-tasks. First one is to actually kind of declare or take this course into your curriculum. Then you have to find out where the material is, where the course is held, where the classes are, who is the professor, and so on. And maybe do the first homework, then do the second homework, and so on. And if I fail in certain point, the smaller the functions are, the easier for me it is to kind of understand what exactly went wrong. Because if I just get an error that this subject failed, or taking this subject failed, it's still quite large problem for me to tackle. But if I see that, for example, understanding who the professor is failed, then I can start working on this concrete small problem. So yeah, we divide our code into smaller functions, and then if we test something, we can see what's the problem with this concrete function. So we can say that, for example, if you have some device, let's say it's whatever device, some electrical device, and if I try to see what's the problem, and let's say this is a, I don't know, mobile device or something where I can send in some information and then I can get something out. So if I send in, let's say 1, I want to get out 2, for example. Now I try to send in 2, but I get error, for example. Now it's very hard for me to kind of see what is the problem actually. Of course I can go to a shop and say that this device doesn't work, but if I want to repair this device, it's very hard for me to actually start repairing it because it contains of smaller components which are kind of connected and so on. So the input goes into the first component and then to the second component, and maybe depending on the value it can be separated into different components and so on. So instead of testing it, so of course this testing is also maybe required. If there's no problem, there's no point to maybe test all those smaller components. But usually what we do, we test this one separately. We check if I pass in 1, what's the result. So let's say this is converted for some reason into A, and 2 is converted into B, which is okay. Maybe this component is okay also, but in here, let's say we have, for some reason, now we have 7 here, and 7 outputs 2, so this component is okay. But if the input is 8, then it gives us error. And now I can work with this component or replace this component and so on. So that's the idea. We divide bigger problems or bigger tasks into smaller tasks, which also can contain sub-tasks and so on. So it's very common to have a huge problem or huge function or problem to solve, and we have several smaller functions, and inside those functions we also use smaller functions and so on. So basically what I did with the study here, with study we first divide it into years, maybe, then we divide it into semesters, then we maybe divided those into subjects, and inside subjects we also have some smaller tasks. So it's very common for a programmer to do. It's also quite nice. It gives you, I mean, this sub-tasking and then dividing problems into smaller tasks, it's something which helps you in your life also. So it's often when you have to tackle some problems, instead of taking a huge problem, you usually want to divide it into smaller tasks. And then it's easy to kind of have a to-do list where you can mark things done. So the smaller the tasks are, the more you get, more joy you get from checking those tasks. So instead of having one to-do list which says that finish your studies, instead you probably will want to have items for every year or even for every course. So for course A, course B, and so on. So it's nice to kind of, in the end of semester, you can check some boxes here. Otherwise, you maybe have to wait 3 years to check something. So it's in programming, it's the same. And if you in real life you study those subjects, you try to finish your studies. In programming, what we do, we implement those functions. We divide it into smaller tasks. Then we start implementing those smaller tasks. If the smaller tasks are implemented, then we can use those in bigger tasks. Usually here we just have to kind of use the building blocks we have done here, put them in the right order, and by that, solving the smaller problems, we have solved the bigger problem. This is also related to naming the functions. So a function should do one concrete task. So the study already is not so good name, or the idea of this function is not very good because it contains several different tasks actually. So usually it's better to have a function called get circle area than it is to have a function get circle area and perimeter. So it's already the name says that there's several different things what we are doing. So instead we should divide it into 2. And the function itself should be simple enough so we can have a concrete name about what it does. So the study is not a good name because it's not concrete enough. So it's too general. we don't understand what it is and how it's done, and it is not a code name. I mean, of course, in certain cases you have to have those functions, but I would prefer something more concrete or which basically says what is done in this function. So the good example is from, for example, get word distribution from text. We understand that what it does, it takes a text, it tries to find the distribution of words inside this text, and we get this as a result. But if we have a function called foo, or solve problem, or helper, this is very general. I mean, solve a problem, what kind of problem? I mean, in one problem or one program, we usually have several problems. So if I say that solve a problem is a function, then it's, I mean, I wouldn't understand which problem we are solving here. Also helper. Helper for what? I understand that it helps us to achieve something, but what? So instead, try to use the function name in a way that if someone else uses your code or wants to write additional functionality to this code, using your functions already gives a quite good idea what the function does. Of course, I can check always the docstring. So in docstring you can have more text and give examples and so on, but still, the better or the more concrete your functions are named, the better it is for others to use your code. Of course, for you also, because in maybe several months, if you haven't checked your code, you want to do something, it's often quite hard to understand what you did several months ago. So try to structure and name your code in a way that next time you see your code, everything is quite clear. But this is something we are dealing with in this course, and it's quite normal that after this course you still don't get all those ideas. But this is something which comes with experience, although we try to point out certain places or in certain exercises how it should be done or why we have done it so and why you should do it in that way. So as a conclusion, we can say that often it's easier to write code than it is to read code. This is especially case you can try out that you write some code in the first weeks of this course and try to read this code in the end of this semester, in the end of this course, and maybe you understand what I meant here. Often we tend to think about writing the code as it is meant only for the computer. Of course, this is true in the sense that you have to write the code so that the computer understands it and it does exactly what's expected. But the problem is that sometimes, or most of the times, someone else or even you yourself have to read your code and do modifications and maybe fix some problems. So the code should be readable for a programmer also. So, and a good programmer ensures that the written code is readable by others. So it's like an author of a good book. So there's no point to write a book which nobody understands or is very complexly written, and it's very hard to understand what the author wanted to say. Of course, there are maybe some authors who do it intentionally, but usually you want your code or your book to be readable, to understandable for others. So, and by saying that it should be understandable, we don't mean that you have to write comments for every line. So there are some people who think that if I have a certain line in my code, I just add a comment here, what it does, and then there's another line and I add a comment here also. There's a special saying, clean code, which we don't cover in this course too much, but you probably get to know about it in later courses. So clean code, the idea behind clean code is that you write your code so that you don't have to write comments at all. This is one of the points. There are actually quite many points about the clean code. But yeah, the idea is to write code so that you don't have to write comments. So if you use meaningful function names, meaningful variable names, you should be able to do that without having comments. So yeah, instead of writing comments, try to structure your code well and try to have them meaningful names for your variables and so on. One example or one thing what can be done, for example, we have a code here which is, let's say there are several lines of code which are complex, and it might be useful at certain points to actually have those comments here. So I have said that those 3 lines, there are also some lines here, so those 3 lines do something complex, and I have written a comment here. What is often done is that instead of writing this comment and having 3 lines here, we will extract it into a function. What's good about the function is that a function has a name, and by the name I can give hints what's done here. So there are 3 lines of code, but if I write it into a function which says that calculate the average salary for the employee, then instead of those 3 lines, if I call out the function calculate average salary for employee, then it's already more understandable. And basically the text which was here, I can use it as a function name, or of course not exactly the same, because I have to apply the rules for naming, but still it's one way to kind of reduce the complexity. So instead of a lot of code, so we have 100 lines of code, instead I divide it into smaller functions, function calls, and with the function calls I can kind of have more verbosity about what's done in those 3 lines. Of course, I also can add it to docstring, so if I'm interested in how it is done and what's exactly done, I can read the docstring, or even if I really want to know how it's done, I can check the code here. But I give the opportunity to kind of read the code quickly if I don't care about those 3 lines exactly. I just want to know, oh, okay, it's calculated the average salary. So I can just see that the average salary function is called here. It's put into a variable. I don't care about how it's done. So that can be achieved with functions. So some suggestions about functions. Usually function length should be then up to 10 to 15 lines. Of course, there are cases where you, for some reason, need 100 lines of code. Often functions are even 2 lines or 3 lines of code. So if you see that your function exceeds 10 or 15 or 20 lines of code, you should think that maybe the function is too big, or you might want to divide it into smaller functions and so on. So of course it's not 100% the case, but often it is. So before writing the code, try to fix the structure. By structure I mean something like that, what I've done here. So before you actually implement the code, how to declare a course, how to find the materials and so on, you try to see the bigger picture. You divide the bigger picture into smaller pictures or smaller tasks, and maybe even sub-tasks and so on. And this is often what is done. So you lay out the structure, you maybe even write the code so that you put in the function definitions, but you don't write the actual code inside those functions, but you kind of have dummy functions, so the function names basically. Yeah, and that's the idea. You divide the functionality into smaller functions. So just an example. So for example, if you have a program which wants to check whether ID code of a person is correct. So every country has different rules, but let's say we have a concrete country, we have concrete rules, and every person has unique ID. And then instead of having one function which checks the ID code, which is also hard to test, in a sense that the ID code usually contains different parts, and every part has different rules. So if I see that the ID code is invalid, it's very hard to see why. So instead of checking the whole code, I divide it into smaller problems. And those can be check gender, for example, check month, and so on. So for example, in Estonian ID code, we have gender, we have date of birth, date of month, year, day. Then we have some checksum and so on. So every part can be actually validated separately. And it makes sense because the whole code for checking the whole ID number would be long, and it would be hard to test and so on. And it would be maybe hard to write because you see that you have to write 100 lines of code. And maybe it's not so kind of, it can be intimidating, but instead we write it into smaller tasks, and then I can say, let's do those 2 tasks today, and tomorrow I will finish with other tasks and something like that. So, and if you have kind of put or fixed the structure as I did here, then it's kind of convenient to start implementing those smaller functions. Here's an example. So the check ID code, where I put in the code, it can contain different calls to different smaller tasks. So here's an example. I have divided it into 2, but actually there would be more. There would be check gender, check month, day, year, check checksum, and so on. So there are different function calls, and I can do something there. Of course, here it's simplified, but usually this subtask can return something, and I can use it here. So every subtask returns something, some value, some result. For example, is it valid or is it not valid? Is there an error? Is it true? Is it big? Is it small? Is it 7? Whatever. I can get those results from the subtasks, and now I can use those values or the results inside my bigger tasks. So basically, with functions, try to divide your code into smaller functions. Every function can also contain or have contain calls to even smaller functions, as is done here. And the smaller the functions are, the easier they are to read, the easier they are to implement, the easier they are to test. So try to keep them small, and it's also more convenient to implement your code. If you have to write small tasks, you can implement some of your code in one day and continue on the next day. It's harder to continue your coding if you have done, let's say, 40 lines of code here, and now if you continue the second time, you have to kind of remember or maybe even have to remind what has been done here in your code earlier. So maybe you did something this week and now you continue in 2 weeks' time. It can be hard to continue the one function, so it's easier to implement one function in one session, yes, and then you can continue from here. But usually functions are independent in a way that, of course, you can put in some values, but this function should not depend on this and this and this and so on. It can depend on those values, what they return, but usually every function should be separate in a sense that you only can get in something, you can return something, but it doesn't affect the contents of other functions, and other functions cannot change the content or the behavior of this function. So write short functions, give them meaningful names, and then it's easier to maintain your code.